Julia is a high-level data programming language. Introduced in 2012, it not only provides but also compiles many sophisticated tools for programmers when creating content. The following are the four main topics which we will focus on during this video. Let's begin with its usage. In order to build software, up to 4 different languages may be required, and as a result, many complications can occur. Today's languages were each designed with different goals in mind. MATLAB was built for matrix calculations and its great linear algebra functions. The OR language is meant for statistics. Ruby and Python are good general-purpose languages beloved by web developers because they make coding faster and easier. However, they don't run as quickly as languages like C and Java. In an attempt to solve this problem, Stefan Karpinski, Jeff Bezanson, and a number of different computer scientists set out to develop a single language that does everything well, called Julia. Programmers often use tools that translate slower languages like Ruby and Python into faster languages such as Java or C, but the faster code must also be translated, or compiled, into code that the machine can understand. This adds to the complexity of the matter and increases the chance of errors. However, Julia doesn't need this intermediary step. One advantage of Julia is the concept of multiple dispatch, which enables users to find function behavior across a combination of argument types. This provides a dynamic type system broken down into types, enabling greater abstraction. Julia gives us the power of abstraction, which gives us performance and allows us to deal with large data and create programs very quickly. It can also offer an alternative to Hadoop in that it can take large problems, dissect them, and spread them across hundreds of machines. Next, we move on to Julia's application. There are 3 main ways you can run the program. Firstly, there is an application called Juno, which is an integrated development environment platform and can be downloaded from the Julia website. This is usually downloaded for tutorials. Next is the online platform on juliabox.org, which is a Julia notebook. No installation is required and full tutorials are available online. Just point your browser there, log in, and start computing. Finally, you can download the Julia Notepad itself on the Julia website. To provide a more comprehensive look at the matter, we've included a demonstration from the Julia Notepad itself. This is being performed on the iJulia Notepad, which is free to download on the Julia website. Here is a simple 1 plus 2 question. Once the formula is created, press Ctrl and Enter to run Julia, and the answer 3 is produced. This is an excellent example to show us how Julia can produce random numbers quickly in rows and columns. To reset, press Ctrl and D. If you have ever worked with OR before, you will notice that this is a very similar system, but uses simpler code. Another application of Julia is using the iJulia Notepad. Here we can see it used through Gadfly. As you can see from the diagrams with simple Julia code, it can be very colourful and presentable. This paves the way for fully cloud-based operations, including data management, code editing, sharing, execution, debugging, collaboration, analysis, data exploration, and visualization. According to the creators, the goal is to let people stop worrying about administering machines and managing data and get straight to the real problem. Here is a visual representation of Julia benchmarked against other languages with regards to function calls, string parsing, sorting, numerical loops, random number generation, and an array of other operations. Julia's creators assure us that the code of Julia should feel familiar to anyone who has previous experience in programming mathematical languages. From the above table, it is clear that Julia is a rapid language. As Julia was only developed in 2012, it is still a relatively new technology. It is in the developmental phase, so support for it is currently limited. Its intent is to try to bridge the gap between high-level languages and lower ones, in terms of giving the user the power, flexibility, and general-purpose usefulness of a Python-like language. In multiple ways, Julia is very similar to Python and R, as they are all dynamic programming languages. It also takes advantage of the just-in-time compiler, which leads to faster runtimes and a more effective process. Another advantage of Julia is that it is very good for statistical programming due to its extensive math capabilities. A user can work with extremely large numbers, including those with decimals, which is generally uncommon in programming. Some of the benefits include a sophisticated type system used to generate code programmatically. Julia is perceived as high level, which usually means it's easier to learn, with a multiple dispatch function. It allows for users to be highly involved with the creation of language, as users are in fact developers. And furthermore, Julia is quickly developing a reputation for speed in its programming code. As Julia is only 3 years old, many programmers are unaware of it. Due to its newness, Julia does not have the support systems that other leading programmers do. In addition to this, it is not as stable as Python or R. The language itself and the libraries of Julia have not fully stabilized and are likely to take some while to do this. Julia is a very niche language and is currently in the developmental phase. As it is still in its infancy, Julia does not yet have the same success stories as some of the other leading programs. Julia's ability to operate in technical, numerical, and general-purpose language means it is used in production in several different areas. It provides functionality for such diverse disciplines as bioinformatics, chemistry, cosmology, finance, linguistics, machine learning, mathematics, statistics, and high-performance computing. Here are just a few examples of some of the major players that use Julia in production. These include McAfee, Facebook, Capital One, IBM, Symantec, and Disney. Since its inception in 2012, Julia has gained popularity, with particular growth seen in Europe and the United States. This is demonstrated through the RedMonk Programming Language Rankings. These figures correlate to language discussion and usage in an effort to extract insights into potential future adoption trends. Having jumped from 63rd to 56th on the rankings in the space of a year, Julia is proving to be a popular source of investigation and experimentation. Overall, we see Julia as a hugely promising computer programming tool, one which has a bright future and one which we expect to see a lot more of in the near future.